Hey, this is Mr. Wharton. I'm doing a video key on the exit ticket 17.1. We're going to consider that same class with the 12 girls and 10 boys and the hat containing all names, only this time the teacher is expanding the committee to 3 members. So, what is the probability of 3 girls? Well, you start off with the probability of the first girl, which would be 12 out of a total of 22 people's names in the hat. Now, after that first girl is drawn, then there are now only 11 girls out of 21 names in the hat. And then there are only 10 girls out of 20 names in the hat. So you're going to multiply 12 times 11 times 10 over 22 times 21 times 20. Okay, and that can be simplified a bit, but I'm going to go on to a Desmos, and I'll show you how it might look there. Copy pasta that into Desmos, okay, into the graphing calculator. So I don't like the way that's formatted, so I'm going to reformat it. So it's going to be 12 over 22 times 11 over 21 times 10 over 20. Now, we can do, before I do all this calculation, of course, you get this number, which is just 1/7, by the way. That is 0.142857148,257. But let's go ahead and tidy this up. We can cross-reduce 11 and 22 and make that 1 and 2, because 11 over 22 is 1/2. We can also reduce 10 over 20 and make that 1 over 2. And then, of course, these two 2's or make a 4. 2 times 2 makes a 4. And that can factor a 4 out of the 12 up here, leaving a 3. So that becomes a 1. And this one contributed to factoring out the 4 as well, so that becomes a 1. So we no longer care about the 1 over 1. And now we've got 3 over 21, which is 1 over 7 when we factor a 3 out. And so we now no longer care about that. So there is a 1/7 chance of, or 14.3-ish% chance of drawing 3 girls. So that becomes 1 out of 7 chance, which, or about 14.3%. Okay, there you go. That is that one. Now, the next one, what's the probability of no girls? Well, to calculate that, the best way to do that is to calculate the probability of all boys, because if it's all boys, then it's no girls. So the probability of all boys and 3 pulls, there's 10 boys out of 22, and then times 9 boys. Once the first boy is drawn, 9 boys out of now 21 times 8 boys out of 20. And so we calculate this the same way. So I'm going to go ahead and organize that in Desmos. 10, 9, 8. So it's 10 over 22 times 9 out of 21 times 8 out of 20. Okay, and that's a somewhat more complicated one, but we can start simplifying things. The 20 and the 10 can simplify into a 2 and a 1. Okay, the 8 and the 2 simplifies into a 4 over 1. The 4 and the 22 can simplify into a 2 and an 11. And the 9 and the 21 can factor into a 3 over 7. And we can't cross-reduce anymore, so we're going to have to go ahead and work that out. That's 3 times 2, which is 6. And that's out of 77. Okay, 6 out of 77 is a lower probability of no girls. So that's the probability of all boys, which would mean no girls. So there we go. It's 6 out of 77, or approximately 7.8%. So that would be equal to 6 out of 77, or about 7.8% probability. Did I get that right? Yes, 7.8. Okay. Now, what's the probability of a boy, then a girl, then a boy? Well, we start off with 10 out of 22. Then we multiply that times 12 out of 21, because there's still 12 girls. And then we multiply that out times 9 out of 20, because now there are 9 girls and 20 people in the hat still to pull from. So let's take that over to Desmos and work it out, because I like seeing the fractions vertically instead of like this. It's easier to organize it on Desmos. 10 out of 22 times 12 out of 21 times 9 out of 20. And let's start cross-reducing. So again, the 10 and the 20 can boil down to a 1 over 2. We can factor the 12 and the 21 down to 4 over 7. So that becomes, factor a 3 out of 21, that gets us 7. Factor a 3 out of 12, that gets us a 4. And then the 4 can simplify into a 2. And this becomes an 11. And these 2's cancel out into 1's. So now we are simply left with 1 times 1 times 9, which will be 9, out of 11 times 7, which will just be 77. So once again, we have something out of 77. So it's 9 out of 77 probability, 9 possibilities out of 77. And that comes out to approximately 11.7%. So go in there, put our answer, which will be 9 out of 77, okay, which, or about, what did I say it was? Let's take a look at Desmos again. 11.7. 11.7%. Okay, the final one on this is, what is the probability of a boy, then a boy, then a girl? So a boy, then a boy, then a girl. So that's 10 out of 22, 10 boys out of 22 people, times 9 out of 21, times 12 out of 20. Now, you might notice 10, 12, and 9, 10, 9, and 12 are the numerators. The denominators are the same. So this is going to actually equal exactly the same thing, 9 out of 77, or about 11.7%. So 10 times 9 times 12 is going to be the same as 10 times 12 times 9. And the denominators are all the same, 22 times 21 times 20. So there you have it. I hope that was helpful.